So yeah, yesterday, just like a recap. So yesterday we have seen how to handle different machine learning algorithms. I've shown you like 10 of them, and what are the pros and cons of each algorithm of ML, and when to use what. What are different types of like supervised, unsupervised learning. And then we started a project on house prices regression, where we'll be having the data of a particular house, like area, bedrooms, bathrooms, stories, and all. And we have to use the prices. We have to find the pattern between them, and we have to find we have to predict the price for a new house. That is what the project is for. A normal house price prediction model. And this is a completely regression project. Why? Because the prediction that we are going to make is not a category based, it's a continuous variable based. So it is a regression project. And we have taken our data from Kaggle. We have directly imported it from the Kaggle dataset instead of downloading it and uploading it. And we have written all the important imports that we'll be using throughout the project. And then we have read the CSV file. We have understood the CSV file. We have seen what are the columns in it, what are the missing values in it, what are the data types it has. We have seen there are a lot of object data type, and we have used something called label encoder to convert this object data type into a int, so that you can see your funding status has been converted to a normal zeros and ones, and you don't see any string values. And then we have separated our feature columns and target column. And after separating it, we have created train, test, and split data. And after doing that, we have just written the models that we'll be using in this project. So till here, any doubts, anyone from the previous class?
Request. This file, I think I lost the link.
Oh, this collab file?
You shared it yesterday.
Yes, I shared.
Thank you. Yeah. Thank you. Yeah.
Okay, so now we have all the models written. Now our end goal is we have to train the model. We have to train each one of the model that is given here. So let's train it. Results of the model and the prediction table. I'll be creating a prediction table since we have 4 models here. Usually the process that I've seen with some of the engineers is they train each model separately. I mean, each model is trained separately, and then for each model they take the MAE, RMSE values and R-square values, and then they try to check it at the end. Instead of doing that, it's a long process. Instead of doing that, what you can do is you can train all the models at once. If you have 10 models and if you want to use all the 10 algorithms, 10 models at once, you can do that. I'll show you how to do it. And I'll also show you how to create a prediction table so that all your models predictions, the results of your models will be stored in one single place and you can easily visualize them. I'll show you how to do that. Data frame, and we will create actual price y_test dot insert index. Why I'm facing this error? Yep. So we created a data frame with ytest. Here dot reset index will act as the starting point. For name model in. If you're wondering why I'm using name comma model, here if you see on the top, models is a dictionary. It is not a list, it is rather a dictionary. And in dictionary, whenever you're using a for loop, you have to use two indices. One is for the key and the other is for the values. So here name is for the left side loop and model is for the right side loop. So that is the reason I have used two indices here. Name comma model. Name comma model in models.items, model.fit, xtrain and ytrain. So here this line, what it does is, for here the model will be replaced with the linear regression, decision tree regressor, random forest regressor, k-neighbors regressor. So each time it will first train the linear regression, then it will train the decision tree regressor, then the random, then the k-neighbors. So that is how this line works, model.fit. Predictions equal to, so fit is completed. Whenever you're training a model, you have to do, I mean, from all the projects, we are doing two things. One is fitting the model to train the model, and then we are doing model.predict. So preds equal to model.predict x of test. You already know this. Training will be happening in x of train and y train, and test prediction always happens only on x test. This is common for every project that we do. Prediction table of name. Here if you see, I'm not depending on auto completion. I wanted something else. So what I do preds dot round of 0 dot as type int. Why I'm doing this dot round of 0 is, you may be having some decimal values. You may be having something like 42.687 something. So instead of getting that decimals and that like point so and so, I want to round it up to a proper integer. So that is why I'm using round of zeros. A round of 0 is nothing but rounding to the nearest number. And as type of int will convert a normal, it can be any decimal value also, to a proper int value. That's why I'm doing as type int here. So what we thought of identifying MAE, which is mean absolute error, which happens on ytest and preds. Next RMSE. For RMSE, you have to do np.sqrt of mean squared error ytest comma preds, and finally R2 score ytest comma preds. Here if you see, in our last project also, whenever you're trying to find a metric, we have always done it for ytest and predictions. That is because whenever your professor is correcting your mocked answer sheet, he will check your answers that you have written, and he will check the actual answers of the mock test. So the same thing is happening here. Ytest is the mock sheet answers, preds is the values that you have entered. I mean, you got whatever the predictions your model have made. And all of these three operate only on ytest and preds. If you see, all of these three has same parameters. Now I have to send it to the results table so that I can visualize it in a beautiful manner. Results.append. But instead of appending it as a list, I will append it as an object, key value pair. So it will be much more neat. Yeah, this is good. Model name, MAE is MAE. So here I always do int of, so that in any case, if there is any bug in the MAE, it can, if it goes to somewhere like a string or a decimal, it always converts back to integer. You no need to do it, but it's a good thing to always follow. Whenever you're printing out MAE, make sure you're printing it as an int type. And it will be usually in dollar format because the output is in dollars. MAE also will be in dollar. This also will be dollar. RMSE and R2. For R square, usually I do round off R2 comma 4 up to 4 decimals is what we do, because R2 number will be huge, and I said right, it is the absolute mean of MAE and RMSE. So whenever you're doing absolute means, you will get in decimals sometimes. So I'm doing up to 4 around, but again, this is completely optional. You can also put it as int. Results of data frame equals to pd dot data frame of results, but still it is there. What I wanted to do is I want to sort the values, based on actually by R2 is not required. Yeah, just sorting the values RMSE of dollar dot reset index of drop. Even if you remove this reset index here and here, nothing changes, but I always make sure to reset the index to the first index on everything that I print or anything that I create, so that in the program, anywhere if my index goes to like 1 or 2 because of any loop, it resets back to the original state. It's a clean code, but it's a completely optional thing. Just to avoid any other kind of bugs, I do this. Okay. And let's run this. Oh, my bad. So yeah, I've done a mistake here. So the thing is, I have written all of this inside the for loop, but here from here it should be outside the for loop. So it should come here for the indentation to work. Yeah. Now let's run it. Yeah, you can see the values. So you have linear regression, MAE value is this much, RMSE value is this much, R2 score is this much. If you remember, I told you that if R2 score is greater, that means it is a good model. If R2 score is less, then it is a bad model. And if you can see also here, the MAE value of the error is something around $979,000 around. But for the others, it is way big. MAE and RMSE values should be lower. R2 score should be higher. Then we say that the model is good. So according to the evaluation that we got here, linear regression is the best model that got the 64% accuracy. Random forest is the next one. Decision tree is the next one. K nearest neighbors is the last one with 0.3605. That is 36%. Now let's also plot it. Or else before moving forward, let me talk about MAE, RMSE and R2 score in detail. I'll tell you how is MAE score calculated. Okay. So let's take, there are three houses. There are three houses in the data set. House 1, house 2, house 3. Okay. Now the actual price of house 1 is, let's say, 300k. 300k. And house 2 is, let's say, somewhere around 450k. Okay. And house 3, let's say 200k. Now, after my model prediction, I mean on the training data, I have done some predictions, right? So my model predicted that this is actual data. This is the predicted data from the model. My model predicted that the house of house 1 is 280k. And house 2 is something, let's say, 470k. And this one, let's say, 210k. Okay. Someone added. Yeah. It's, let's say, the actual is 300k, 450k, and 200k. And the predicted values are 280k, 470, and 210k. Now, what is the difference between the actual and the predict? What is the difference between the actual and the predict? So for example, in house 1, the difference is around 20k. And in here, the difference is again 20k. Okay. And here also it is somewhere around 10k. Now, MAE is calculated. MAE equals to 20,000 plus 20,000 plus this 10,000. And how many are there? 1, 2, 3. So total divided by 3. So it will be 20 plus 20, 40, 40 plus 10, 50. 50k divided by 3 will be 16. 16 around 667 somewhere. It is 666 or 667 something. So you will get this much. This will be your MAE. And this is how it is calculated. This is how MAEs are calculated. Now I have given example of only 3 houses. Imagine 100 houses. Imagine 1,000 houses. Imagine 10,000 houses. Okay. If you have 10,000 houses, all the differences of the actual and the predicted values, the sum of all of them divided by the number of houses, and you will get the MAE. Any doubts on how to calculate MAE? Because this is an important one. You can get it in exam. This is an answer asked in exams, or sometimes it can be asked in interviews. Like a simple how do you calculate MAEs can be asked in the questions in the interview rounds. So any doubts, anyone, on how to calculate MAE? My screen share stopped, right? I don't know why it's keep on happening. Yeah, I'm sharing it again. Yeah. Anyone, any doubts in MAE? If anyone have not understood, please let me know. And one more thing you have to note here is, you can argue with me, Monesh, here it is 300k and minus 280k, you got plus 20,000. But here it is 450k, Monesh, and here it is bigger than this. It is 470k. So if you do 450 minus 470, you have to get minus 20,000, right? Then why did you add plus 20,000 here? So here you are only calculating the difference, no matter which is small and which is big. Always take the positives values. You cannot you should not calculate like 450 minus 470. You should calculate in a way that take the bigger number out of these two and subtract the smaller number. Always take the bigger number in both of them and subtract the smaller number, so that always you get the positive value after subtraction. Any doubts in MAE? Again, I am asking. If anyone have any doubts in MAE, please let me know. This is an example of only 3 houses. If you have 50 houses, all the 50 houses actual prices, all the 50 houses predicted prices you will find the difference between them. And after finding the difference, you will be adding all of them and you will be doing divided by 50. How many houses are there? You will be doing divided by those much of count and you will get the value. So here when it says MAE is something around 9,79,000, it has calculated in the same way. It has found the difference between each actual and predicted, and then it has done a summation and it has divided by the count of the training data. So any doubts, anyone, again, before moving forward? Because MAE is important. If you don't know what is an MAE metric, you don't know what is supervised learning. You cannot do projects in it. All good, right? MAE. Okay, thank you. Come. Okay, but please don't hesitate. So Monesh, what is the use of it, Monesh? Why do we need only MAE to? Why are we using only MAE as a metric to score the model? Why can't we use something else? There are a lot of ways to actually score a model. But for supervised learning, especially regressions, MAE is one of the best metric to score a model. It is super easy to explain to anyone. See how simply with a diagram I can easily explain it to you. You can also explain it to anyone. Even to a non-technical person, you can easily understand, you can easily teach what an MAE is. It is super easy to explain to anyone. It stays in the same unit as the target, which is the dollars. If the target is in dollars, this will also be in dollars. If the target is in an integer normal value, the MAE also will be in the normal value. If the target is centimeters, MAE also will be in the centimeters. It always carries the same unit. And also it treats every error equally regardless of the size. No matter the weights of the data, each and every row is treated equally. And it is also a very good aspect for business reporting. One of our friend Gagan yesterday talked about sales data, right? So if you are talking about regression model on a sales data for predicting something, which will be a project in the next class. But for these kind of purposes also, using MAE as a evaluation metric is much more helpful for business reporting purposes, because MAE acts on dollars, on real money. So you'll get a good gist of on the outcome. And there are also some places where MAE can mislead you. I talked about the pros. Now I also have to talk about the cons. MAE does not care if one prediction was off by 5,000 or 200k. It doesn't care. Both errors get treated proportionally. That is one of the huge problem with MAE, which is solved by RMSE. The problem of MAE will be solved by RMSE. So if it does not care if one proportion was off by $5,000 versus 200k. For example, Monish, what are you talking about? For example, this can be $200k difference. And the next one can be only $20k difference, and the next one can be only 10k difference. So this huge difference between this 200k and 20,000 will lead to a bigger impact, which cannot be drawn in this MAE. That was the problem of MAE. both errors get treated proportionally equally. So that is one of the biggest cons of using an MAE. And if your business cannot afford large single misses, MAE alone is not enough to predict a model. For that, we started to use RMSE also along with MAE. RMSE. This is the second metric. That's why whenever you're coding, you don't only write MAE, you also do it in RMSE and you'll find the R2 value, R square value. Okay, Monesh, now what is RMSE? RMSE means root mean squared error. Root mean squared error. What is this root mean squared error? It is similar to MAE. It is very similar to MAE, but it punishes large mistakes much more heavily. What are you talking about, Monesh? Very simple. Whatever the difference that you found here, you have to square it. You have to square it. In the sense, this is 20k, right? Originally, this is 20k. Okay, 300k minus 280, so 20. So what is the square? What is the square of 20k to 20k? It is around. Let me write here. 20k, right? So it will be around house 1. What is the value? What is the MAE values that we have here? MAE values is 20k. For this 20k, you have to do square. You do squares, right? 2 square, 3 square, 8 square. Like that, you will be squaring the value. If you square the value, you will be getting something around 400. Again 3 zeros. And again you have to put 3 zeros. This will be the value. If you do a square for a square of a 20k, let me check 1, 2, 3, 4, 5, 6, 7, 8, 4. Yeah, correct. So there are 4 zeros. So 4 zeros will be squared. So there will be 8 zeros now. So that is it's a simple way of calculation. So if there is 20k, you square root it, you will get something this amount. Let's do for house 2. What is the MAE value of house 2? Again 20k. Again 20k. Let's do square of it. If you square of it, again the same value. Okay. House 3. What is this MAE value of house 3? It is 10k. 10k. Again square. This time you'll get something around 100. 1, 2, 3. 1, 2, 3. Yeah, correct. So the average of these three average in the sense you have to add these 3 things. Like you have to add house 1, house 2, house 3, and you have to do by 3. So you have to do plus of all these values and you have to divide it by 3. Add all of this and you will divide it by 3. If you divide it by 3, so it will be 4, 5. I guess the average should be around 300. For that also we have to do square, so you will get something around this much, and then you have to do a square root of this average. Square root of this particular average. If you do square root of this 300 of what we have here, then you will get around somewhere like 17,320 around. I'm not sure if this is the exact number. Yeah, it should be 1732 around. I'm not, this can be wrong, but yeah, you will get something around 17320. That will be your RMSE value. This is how RMSE is calculated. You square the each number of the house prices values of MAE, take an average of them, and after taking the average, you do a square root, and whatever the square root you get, that will be your RMSE value. So if you see here, MAE value is 16,667, RMSE value is 17,320. So that is the difference here. Now, if you think, Monesh, here in both the cases they are same. No, Monesh, here it is 16,607 something, and here it is 17,320 something. Then what is the difference between MAE and RMSE, and why are we doing it? Here I'll show you the beauty of why we use RMSE. Suddenly, let's say this house 3 is there, right? Suddenly you take it, imagine it as a huge error, like 40 trillion dollars something, like 40 followed by 1 2 3 4 5 6 7 8 9 10 11 something. Like, think that it has a huge error margin for house 3. Then suddenly RMSE increases to something around like 115,470 RMSE value, but the MAE values remains the same. MAE values will be changing from 16,000 to, let's say, 70,000, but RMSE will be changing drastically. That is what RMSE is used for. Whenever you have a error that has a bigger outlier that can destroy the average, the RMSE value will expand to a very bigger level. The error of RMSE will be going to a very extreme level, whereas MAE will be only moving slightly to a bigger amount. For example, here from 16,000 it will be maximum going to 70,000, but RMSE will be going from 17,000 to 115k. So that is why RMSE is used, so that whenever you have a very big errors in between, easily it can be identified by RMSE. And why we use RMSE is sensitive to outliers and large mistakes. And if predicting a 500k house as a 100k is a catastrophic for this kind of prediction business, so RMSE will clearly show that. When you look at this code also, if you see that RMSE has a very big value, then immediately you will come to know that model is wrong. That model itself is somewhere wrong. The algorithm is wrong for that model, and you will easily identify it. In MAE you cannot identify it. In RMSE you can identify it. And also it is the standard metric in most ML competitions and papers. In Kaggle or in Hugging Face that I'll talk about, in any competitions you go, most of the times your model, the accuracy of your model will be calculated by using RMSE. The competitions will calculate your models on RMSE. If your RMSE is good in the sense, if your RMSE is low, which states that your model is good. Yeah, any doubts here? Again, I'm saying MAE value should be low, RMSE value should be low. If MAE value is huge, it's okay. If RMSE value is very big, then it is a problem. Yeah, any doubts in RMSE? You square each value, get the average. For the average, take the square root. That will be your RMSE. And this is not the exact average. Again, I'm saying it. I just took an example. All of the values that you see here are examples, not pure mathematics. I'm just giving a gist on how to calculate. Recently, one of my code that I have done, the value is something this, and I know that the square root of this is 17,320. I mean, recently when I did a project, I got this. That's why I took this number. But in reality, the average is not this 300k. It is something. But just to make things easier, I have written 300k here. Any doubts with RMSE? Anyone? Please don't hesitate. If you have not understood, please let me know. Because MAE, RMSE, R square. Very important. Yeah, thank you, Kamla. Okay then. So let's move to, again I'm saying, right, MAE, if MAE value is little bit high, it is okay. It's not that the model is bad. Please understand what I'm saying. If MAE value is 70,000 also, it is okay. It is okay, fine. But if RMSE value is very big, that means that somewhere something went wrong. RMSE value and MAE value should not be that much difference. If you see in all our models, they are not so different. It is 13,000, 17,000, 12, 16, 10, 13, 9, 13. It's okay. They are okay. It's not like this is 13 and that is 56, right? So it's okay. The error rates are not too high, is what I understand. But the accuracies are bad. Now let's talk about R square. What is this R square, Monish? So initially, all of the ML engineers started with MAE. They found out the problem with MAE, then they moved to RMSE. RMSE only talks about the exploded error values. So then they thought, okay, this is not good. Let's do one thing. We will use this MAE and RMSE and we'll call something called R square. R squared is nothing but R squared talks about what percentage of the price variation in the data set does your model actually explain. That is what R square talks about. And how it is calculated is, you compare your model's errors against what would happen if you just predicted the average price for every house. Or else I'll just write the formula. R square equals to 1 minus model's error. That is the model's error, I mean the MAE values. Model's error divided by error of, what is the good line to put here? Errors of always predicting the mean. Always predicting mean. So the model error divided by the mean, you will, and 1 minus of all of this, you will get the R squared value. And if your R squared value is less, which means the model is bad. What I wanted to say is, if your R square value is 1, it is the perfect model. It is the perfect model with zero error. Perfect. It is a perfect model. If your R square is something like 0.85, it means that 85% of price variation, I mean 85% you have guessed it correctly. That is what 85% means. 85% means whatever the prediction you have done, it is 85% correct. That is what it means. So 0.85, something like that. If it is R square equal to 0 or less than 0, then it is a very bad model. You should not consider that model at all. So that is how R squares are. And for example, average house price, let's say, to talk about an example, let's take the average house price of all the data set. The average house price in the entire data set is something like 343. Monish, how do you get this average, Monish? From where did you get this average? In the code, you see here, right? Mean. When I do df.describe, I get the mean value, right? Mean value of the price. That is your average. Your mean value of your price is your average. It is something like 4.47,000 something. I mean 47. I think it's billion around some value. But as an example, I'm taking this number. Let's say your average price of all the houses is this much, and a worst model will say that every prediction is 343k only. It will say that every prediction that you made for any other house will be 343k. So if r square equal to 0.82 means it will be something like 1 minus the model's error. Like let's say MAE. Where is MAE? 16,667, right? 16,667 divided by the error of always predicting mean. Let's say 343 around. You calculate this, you'll get the r square. Something again I'm saying the values are not correct. These are just my imaginary numbers that I'm putting it here, but this is the gist of it. This is how you'll calculate r square. And am I missing something? Yeah, you should only compare this one. Sorry, this one. Most of the times in interviews, right, they will be asking about MAE and RMSE. They won't go too depth with r square is what I have seen, but always remember this formula. You can also look it up in internet. R square equal to 1 minus model's errors by error of always predicting mean, the mean, the average. So whatever 1 minus the model error, whatever you got for MAE divided by the average, you get r square. If r square equals to 1, it is perfect. If r square equal to 0.5, it is okay. If r square is equal to 0 or less than 0, it is worst model. And by just looking at the r square also, you can justify what kind of model you have. 0.64 in the sense it is 64% right. And out of all the 4 models, linear regression is the best one. MAE is lower than all of them. RMSE is lower than all of them. R square is higher than all of them. So linear regression is the best model out of all the 4. Yeah, any doubts now for MAE, RMSE and R square? If any doubts, please let me know. I hope all good. But yeah, if any doubts, please let me know. I'll re-explain. Again, coming to this code one more time. This is the most important cell of our entire project. If you understand, this is the important code of the entire project, because the single loop trains all 4 of the models at the same time. And let me walk through like what each line does again. So results, just a empty list that I have created. Then we create the prediction table as a data frame. The first column is the actual prices from the test set. We reset the index, so the row numbers start from 0 cleanly. This is something that shows that you are a clean coder. You're a clean coder. If you don't write this reset index, right? If let's say you're giving an interview for Amazon or Google or any big companies, FAANG companies, they usually look for people who program in this particular manner. If you don't write this reset index and if you just write y-test, right, they understand that you know the concept, but you have not gone too depth into it and you have not understood the cleanness part of it. So using this kind of small tricks, right, it shows that you are a clean programmer. You write clean code. So yeah, that is the reason I've written here reset index 0. So it resets the index and starts with the 0. As we train each model, we will add its prediction as a new column here. And so at the end, we can compare all 4 models side by side at the same rows. That's what happened here. Now the loop. talking about the loop, we are looping through models dictionary we defined in on the top, I think cell number 9. Each iteration gives us the model's name as a string and the unfiltered model object. Here model.fit x of train comma y train. This is where the actual learning happens. The model looks at the training features and the training prices and figures out the relationship. This one line is the entire training process. Monesh, in the entire project, where are you training the model, Monesh? This one line. The entire training of the model happens in this one line. Dot fit, that's all. This is the important line where the model understands the patterns. And the prediction is where the model is predicting the data for the houses it has never seen before. These predictions go into PREDS. Next we have prediction table. Here. Next we have the prediction table, and we round to the nearest dollar and store it as a new column. So after the loop, prediction table will have 5 columns, actual price and 1 column per model. Next 3 lines calculates our MAE, RMSE and R square. We have put it in a dictionary, and I have sorted the values. Again, I've used reset index for clean programming purposes, and I have displayed the values to you. Whenever you get the output, you have to look for the lowest MAE, lowest RMSE, highest R square. That is how you find out the best model. Yeah, any doubts, anyone till here? Okay. Now let me plot the metric comparison, because whenever you show data like this to the clients, right, as an engineer, your end goal is to talk to clients, help them understand what you all are doing. When you give this to the client, they will not understand it. You sometimes they won't see what is this 97,000, what is this 0.64. They won't be able to grasp the technical aspects of your outputs. Always it is better to showcase them, visualize them. There is also a huge complete concept called storytelling, which I usually take up as a class in different batches. Storytelling is one of the primary important skill that every ML engineer should have, because you will be doing a lot of presentations in your job. I'll bring up a class in the future about complete storytelling. I'll tell you how to frame a story, how to tell a story from beginning to the end, and how to add emotional aspects to the technical side of the story. I'll teach you how to do that. So, but yeah, coming back, let's write plots. And for plotting, on the top, I have imported here matplotlib.pyplot as plt. I will be using that import, and I'll be creating wonderful plots now. And there is no one single rule that plots have to be only in this way. Plots are your creativity. However you want, whatever you want, you are free to do. For example, I put 2, 2 in the sense 2 rows space, 2 columns space. It will be a complete square. 2, 2 means the width of 2 rows and the height of 2 columns. That is what 2, 2 mean. But instead of 2, 2, I'll do it in my style. I take 1, 3, figure size to be usually I do 16, 5. Again, there are no single values here. You can put any values you like. You're free to experiment. This is something that I do. Subtitle in the sense the top title part. Model comparison. House price prediction. font size equals to 15. Again, one more time I'm saying, Monish, why are you using font size 15? I don't know. I just you can use 15, you can use 5, you can use 10, you can use 2. It doesn't matter. Whatever I'm doing out of my experience, or what do you call, the thing that I usually write the code in. However I do, in the same way I'm writing it, but there is no one single correct way to do it. Bold and colors. I have some specific colors in my mind. So say 3. I think it's AED. Yeah. Okay. Monish, how are you getting these colors? What does this mean? These are called hex codes of colors. You copy this, go to internet, paste it, and type color. These are called hex codes. Every color can be represented by a hex format. And also I can show you a hex chart. Hex color picker. So yeah, here you can go to any these kind of websites, color picker websites. You can adjust what kind of color you want, in which shade you want, and all. You can just copy the hex. Every color will have an X. Extreme whites will have an X, hex code, and extreme blacks will also have hex codes. So whatever color you want, you can always get an hex code. There will be like lots of combinations that are possible. You can pick any color you like. Some of them I remembered. Out of when you code a lot, right? Automatically, few hex codes will be in your mind, and usually I use the same colors every time. So I remember few that I'll be using. 06 B6 D4 and F5 9 E0P. One 0P 981. Yeah, these are some of the 4 colors I use a lot when doing plots. Okay, axis of 0 dot bar, a bar chart with results. DF model, results of data frame, MAE in dollars, color equal to colors. Right, X label, instead of X label I call title. Title should be MAE lower is better, and set Y label to be, if title is Y label, like Y label will be dollars. Yeah, Y will be dollars. Access. I'm trying to get a very good plot so that it stays with you and you can use the same code to other projects or for your presentations as well. Axis equal to X. Let's put a rotation also of 25. 45 will be 25 will be better. For I comma v, because it is a dictionary, we need two values to enumerate results data frame of what? MAE dollars, and access of 0 dot text will be I comma v. Let's put some separation of 500, and v works. Yeah, HS enter. Font size equals to 9. Why it is throwing an error? Enumerate results data frame MAE. It starts here. Expected in, okay, I comma v in, yeah, correct. So now what I do, I simply copy this and I'll use it for RMSE also. And instead of stov, I use f dollar. Yeah, I use the same code for RMSE and I use the same code for R square. So wherever MAE is there, I'll just change it to RMSE. RMSE model, RMSE, and here it should be access of 1. Actually, all of this should be access of 1. Yeah, this should be access of 2, and here it should be R square. For R square, higher is better. And R square will not be in dollars. So change the Y label to just R square. Axis EX rotation 25, enumerate results of R square. Yeah, this should work. Now let's see the plot. I missed one more value. plt.type layout, plt.show, and why is this throwing an error? Oh, there is no. Still there is an error. Error key error R2. Why is there a key error? I think it is R2 score. No, still there is an error. R2 score. It's executing. the time by yeah, you can see here. So I have created a neat chart for all the three. Now this is how you show it to the clients. Not exactly. Again, this is my style. You can do it on your style. You can maybe put the value somewhere higher. You can change few things here and there, and you can make it much more better. Here they will easily understand now. Okay, linear regression lower is better, so linear regression is better here. RMSE lower is better, so linear regression is better, and R2 higher is better, so linear regression is better. In any case, linear regression is better model, and this is how you do plots. You can use this code. Yeah, you can use this code, and you can show it to the clients. Yeah. Any doubts, anyone till here? And again, there is no one single way to show the plot. You can show it however you want. This is just my way of doing, but you can do it however you want. Okay. And I'll also show you what is the actual price versus each model for the first 10 houses, first 10 test houses. Print actual price versus each model for the first 10 test houses. Yeah, you can see here for the first 10 houses, first 10 test houses, this is the actual price. 406. I mean, it's not 406 also. Let's take 406k. And linear regression has said that it is 520, decision tree 542, random forest 536, k nearest is 388. So this is how the first 10 test data, and these are how the models have predicted the first 10 data. And let's do also plot. Again, a plot will be again time consuming. I'll use AI to do that. Here I want to show one more plot for you. The difference between the actual and the predicted values. But instead of again writing a huge code for the plot, I'll just use generate with AI just to save some time. And if you're wondering how did I get this right side Gemini thing, here you will have an option called generate with AI. And I clicked on generate with AI. If you once look at the code, and if you feel like the code is good, just click on accept and run. And you get the diagram. So these are the actual prices versus the predicted prices of all the four algorithms. Okay. Yeah, before doing the actual prediction, done. Our project is almost done. You have tested the data, you have got the predictions, you have found out which model to use. There, but our right now our accuracy is only how much 0.64, but we have to do fine tuning for it to get to 80% or r square to be 80 or 85. We have to do parameter tuning or fine tuning, and fine tuning, parameter tuning I'll be talking about in the next classes, or if there is time I'll bring it up in the today's class also. But this is for now, this is what our project will do. We have trained the four models, and after training the four models we got the metrics. From the metrics we have understood which one is the best one, and we have created plots to showcase those metrics. Now, before doing the actual prediction of the house, any doubts, anyone till this moment? Good. Also, it should, the code that we're doing here should be updated in the same collab link that I've shared with you. You will see it being updated. So run it and test it also. Test it with different scenarios for better understanding purposes. Okay, then let's give new data, new prediction. So what till now we have the student has only given the mock test. Now we are giving the student the actual test, the actual exam. New house equals to pd dot data frame area. Let's say some 6,000. Bedrooms 4, bathrooms 2. Stories 2. Parking 2. What? Main road 2. Or let's put main road 1, all becoming 2. Guest room, let's say there is no guest room at all. Basement 1. Hot water heating, let's say 0. Air conditioning 0, 0. Let's put 1. There is no hot water, right? So let's put air conditioning at least. Pref area 1. Furnishing status, let's put 1 again. Index 0 is not required here actually. You can all put this into a single tuple. Yeah. Print new house. Or print a new house. Features. Rename. So dot t is for transpose. Rows becomes columns. Just for columns, instead of showing it as rows, I'll be showing it as columns here. Just for visualization purpose for you, to make the output much more cleaner, I'm doing it. Model dot items prediction equal to model dot predict new house of 0 print f name print. I think this should be good. Let's done. Okay, we have a problem. Model dot predict new house. The feature names should match those that were passed during the fit. Feature names must be in the same order as they were in fit. Isn't there in the same order? Area, bedrooms, volume, storage, parking, main road, guest room, basement, hot water, air conditioning, Wi-Fi, function status. Same, right? That's how I remember the features. Price, okay, price we leave it. Area, bedrooms, bathrooms, stories. Okay. Parking should come at the end. Stories, main road, guest room, basement, hot water, air conditioning. After air conditioning, we have parking. Prefer harnessing status. Yeah, correct. Now I think the error should be solved. Yep. So you can see here for this house that came, the new house with the new data, which is not there in your data set at all. Our model predicted that, linear regression predicted that it is around 744, decision tree to be 811, random forest to be 853, k nearest to be something around 731. So we know that linear regression is the best model to rely on. So you have to make sure you have 744 k dollars something ready in your pocket to go and at least look at the house or to purchase the house. Because this is just a prediction. The value can be lower than it. The actual price can be higher than it. But at least from our model, you have to at least have this money through loan or from bank or something. So any doubts still here? If you change any values here, the output also changes. Instead of 6,000, if you put 8,000, it is 744, right? It will change. No. See, it becomes 791. The price has increased because the area increased. So this is how you have a model, and this is how you predict on new data on multiple models, not on one model, but multiple models. You can also use 100 models if you like, with different algorithms. Yeah. Any doubts still here? Any doubts? Anyone in this moment? Thank you. So yeah, let's move on then. Okay, Monish, it is completed, right? The project is completed, right? No, the project is not yet completed because I talked about fine tuning, right? We will also get to that part. There is also something called fine tuning. Our model accuracy is not so good at all. It is some 60%, 65%. It's not good. You have to do something called fine tuning and parameter tuning. But before that, as when you're learning ML, you have to understand how the algorithm actually works. Especially for linear regression, if you remember the pros that I talked about the linear regression, I told one point. It is easy to understand the logic behind linear regression on what the coefficients that it picks to predict the values. So I'll show you that. I'll show you linear regression coefficients, how linear regression algorithm works internally is what I'll be showing you now, because it is easy to show. Especially for linear regression, LR equal to linear regression, models equal to models of only linear regression I take, and I do something called coefficient data frame equal to pt dot data frame data frame. Let's take a dictionary. I like key value pairs a lot. So in key value pairs, feature columns that we have on the top. Coefficient, you can get whatever the coefficient it is using to be lr dot coefficient coef. It is an inbuilt method dot round of 2. When I show you the output, you will understand it better. Round of 2 dot sort values in coefficient ascending false, and I also have to show you the intercept. Print intercept lr dot intercept dot 2f print feature print coefficient dot string dot to string index false, and one more print I'll tell you how to read. Whatever the output you'll get on the top right, how to read it is, if area of the coefficient equals to 233, that means a 1 square feet increase in area is associated with an increase of 12 or 233 in price. Yeah, this is perfect. Now let's run it. Okay, you see this, right? Intercept equal to some 293 blah 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 blah, and feature coefficients, bathrooms it is 10977, air conditioning 78555, hot water 2867, something, all this kind of things, right? So when it says that air conditioning is 785k, that says that if a house has air conditioning, then an additional price of some 785 is added to it. And if the house doesn't have air conditioning, there is a change of $785,000 on the house. That is what this says. If there is an increase, if there is any if one more air conditioning is added, then this much amount is added to the house. That is what they have seen. That is what the pattern talks about. If there is no furnishing status, this much is removed. If the furnishing status is there, then this much is added back. Yeah, and if the area is 235, you see area is 235. So every 1 square foot increase, there will be 235 added to the price. That is what you have to understand from the model. Yeah, again, one more time I'll say from the top. So this cell is specifically to linear regression, and it is one of the most powerful things about this model. You can actually read the logic. LR stands for this linear regression thing. LR dot coefficient, this inbuilt method, gives us the coefficient for each feature. We round it to 2 decimals and sort from highest to lowest. LR dot intercept is the base price. What the model would predict if every single feature was 0. If every single feature was 0, this is what the model predicts. So if there is no air conditioning, this is the value. If there is an air conditioning added, this much will be added to it. And if you see here, if the area of the coefficient says 235, that means for every additional square feet, the predicted value also increases by 235. And if the air conditioning coefficient is around 785K, that means having air conditioning adds this much to the predicted price according to this model. So if the house has inbuilt air conditioning, this much is the price that is being added. And if the house doesn't have the air conditioning, this much will be reduced. This is a high number, but remember, this data set that we are using, is it in Indian rupee or in dollar? Now I'm getting a doubt. Just for air conditioning, 785, who is gonna pay? Let me quickly check it. Did anywhere is it mentioned that it is in dollar or rupee? Rupee, no.
The units and price, it was there. The discussion.
Sorry.
Units of price and area. The second one. Feet square. No.
Yeah, now I imagined it to be dollars initially, but after looking at this, I'm not sure who is gonna pay this much for an air conditioning.
Bathroom is 1 million. So
Yeah. I think it is in currency. It is Indian currency, I guess. Indian rupees or some other currency. It should not be in dollars. It doesn't make much sense for these values. Yeah, I think 785. 785 for a air conditioning house is fine when you're buying a house in India, but I think this doesn't apply to dollars. Is what I'm imagining. Maybe I'm also wrong. I don't have much data about it. From which city, dataset details. Yeah, not there. But yeah, for now, I mean, since we are not into that data set really, but we are into the technical aspects of it. But yeah, let's think that these are under Indian rupee. I will change the code on the top later. I'll change all the dollar symbols to an Indian rupee symbol. Yeah, this data makes more sense for Indian rupee rather than in dollar. Yep. Yeah, I think even 235 also makes sense, right? 1 square foot in Indian rupee, 235 is fine. In dollars, it is different again. Okay, that is a complete separate discussion we can have. But yeah, I think you got the gist of it. Negative coefficients here mean that negative coefficients mean that the feature pulls the price down. If the furnishing status is 0, then it pulls the value down. This much will be reduced from the actual cost if there is no furniture in the house. So this is how linear regression actually work. And next, since we did not get the actual good accuracies, you should also have to check for overfitting check. For this particular data that we have, you no need to actually do it, but I will give you the code so that when you're doing your own project, right, if you want to check for overfitting check is a very important aspect whenever your model is not working properly, so that immediately you will see if something, overfitting problem exists or it doesn't exist. And for that, to check overfitting, we do print train of R2 versus test of R2. Only when comparing the train and test, we will be able to check for the probability of overfitting. Check for overfitting. In model.items, train not model.score, model.items, it should be train R2 R2 score X train Y train test underscore R2 equal to R2 score of Y test and here also I cannot do an X train because this is for overfitting, right? For overfitting, how do we test? We have to check for the students mock questions. We have to check for the students Y train and we have to make the predictions on the X train only, right? Yeah, Y train and X train. Same training data, but the yeah, correct. So the main features and the target feature. Yeah, main features predicted value should match with the targeted training value. Yeah, correct. Y train, model predict X train. And for test R2, what we have to do? Y of test, model dot predict X of test. Yeah. So R2 score on mock data of a student will be based on his mock questions, prediction, the whatever the answers he has written for the mock questions, and the actual answers. Yeah, correct. And what is the gap between them? The gap of train R2 and test R2. The gap of the mocked answers predicted value and the trained predicted value. The gap between these two will be your gap. Yeah, correct. Train R2 minus test R2. You create a flag. The flag says that possible overfit if gap No, it's not like less than 0. If gap is greater than 0, let's take a minimal number to 0. It should not be 0, but it should not be again like 0.50 also. It should be like, let's take 0.10. If gap is greater than 0.10, else no overfitting. Okay. Again, this 0.10 value that I am taking is at least there, if the gap is more than this number, then I say there is a possible overfitting. There should not be that much gap. If the gap is more, I say that there is a overfitting problem. If the gap is less, then I say no overfitting. Yeah, correct. Print train of R2. Let me format it properly with 3 decimal places. And the test also will be test R2 with again 3 decimal places. And gap to be gap of dot gap of dot, yeah, 3 decimal places. I'm forgetting something. Flag print and print if it is a large gap between train and test R2. If there is a large gap between train and test R2, it usually means there is an overfitting. That is how it works. They should be after. Yeah, let's run it. White train was never closed. Okay. Yeah. Now let's see the data that we have here. Okay, before that, let me talk about the code before talking about the output. The cell 24 that we have here, this is the diagnostic cell. We call it as a diagnostic cell. We are checking whether any of our models overfit. When your model is overfitting, immediately you should not consider it. In the beginning of the classes only I told you, whenever your model is overfitting, it's not a good model. Don't consider it at all. If your model is underfitting, also don't consider your model. Only it has to look good between both of them. It should not underfit, it should not overfit. Then only your model is a good model. So in this scenario, decision tree, random forest, k nearest neighbor, just close your eyes and don't use them at all, because it is possible, there is a possibility of overfitting. And for each model we predict on the training data and calculate R square. Then predict on, whatever we have done here that I'm talking is that for each model we predict on the training data. And then we also calculated the R square for it, R2 score, right? We calculated the R square value on it. Then we predicted the data on the test data, and then we calculated the R square on it. Then we compute the gap between these two. After you computing the gap, what machine learning says that if the gap is greater than 0.10 around, meaning the model performs more than 10 percentage points better than training data than test data. Here what I'm trying to say is the prediction is working 10% more than the training data. How can it predict better than training data? So that is where the actual concept comes into place. If you give a student questions and answers, and if he reads it, he'll get to know something, right? When he's going for the mock exam, he's doing better than you giving a textbook to the student. The student is doing much more better than you giving a textbook to the student and asking him to write the exam. He's doing much more better than that. Means instead of getting 100% of the marks, he's getting 110 of the marks. You're understanding my point, right? For the mock exam, whatever the student is writing, the student is performing so well that if you provide the textbook to the student, if you provided the textbook to the student, right, maximum you will get 100%, 100 out of 100. But here the student is getting 110 out of 100. That is what we are checking. So the model is performing more than 10 percentage points better on training data than the test data. So we flag this kind of things as a possible overfit. Again, here the word you have to underline is this possible. I'm not saying it is compulsory it is overfitting. I'm just predicting. I'm just saying it is a possibility, and you have to check during the fine-tuning phase. Now, fine-tuning will come in the later time. But here we are just flagging it. There may be a chance of overfitting. But really overfitting happened or not happened, we don't know. But there is a possibility. Since the training data performed more than the test data, we are having a small doubt in it on how it can perform like that. So we are just flagging it for now. And linear regression, there is no doubt, there is no overfitting. There is no possibility of overfitting in linear regression. So if you look at the results, linear regression will possibly show a small gap. The gap is 0.036, which is a very, very, very small gap. Even with it is constrained by its simplicity, so it cannot memorize in the first place. You can argue with me, Monish, since linear regression doesn't have an overfitting and has a very less gap, it is the best model. No. Why? Because linear regression has a lot of memory loss. It has a lot of memory loss. Even if you give the textbook to the student with questions and answers in the textbook, he still cannot write the exam properly. That is the case of linear regression. That is how linear regression is. It is a very simple model. It doesn't have the memorization power. Even if you, in the exam, even if you put the slips also, you cannot pass. That is the case of the student of linear regression. Next, decision tree. A decision tree shows a large gap with max depth equal to 5. If you remember, on the top, we have used, where is the model? We have used max depth to be 5. So when we say max depth to be 5, the tree still fits the training data more tightly than the test data. That is the reason you may get an overfitting problem. But it may not really be an overfitting. So this all comes into place when you're doing fine tuning. So instead of 5, you will be doing something like 3. And you will be redoing the entire thing. You will get some output. If you are not satisfied with the output, then change it to 2. Again, run the entire code. Change it to 1. Again, run the entire code. That is how you do. That is called fine tuning, where you will change the parameters to affect the outcome. Next, random forest. Random forest also shows a moderate gap. It does overfits to some degree, but the average across 200 limits it. Since it is 200, it limits those values. Again, if 200, right, change it to 100. Test the data. See if the overfitting gap is getting reduced, or change it to 50. See if the overfitting gap is reduced. If the overfitting gap is reduced, the accuracy increases. So you have to change the parameters and check. Next, KNN. KNN also the same thing. KNN might behave differently. With K equal to 5, it used local averaging, which can be noisy. Instead of 5, we'll change it to 3. And we will redo the entire code. So this is how we change the parameters to affect the outcomes. This is also called as fine tuning. Fine tuning is nothing but you change the settings of a model to get better outcomes. Now let's put the cursor here and let's run every cell at the bottom from here. Run focused cell and all cells below. Yeah, so from this cell it starts to run all the cells at the bottom. So let's give it time to run, and we'll take a break, a 20-minute break, a 20 to 25, and we'll meet back. Wait, see here. Now from 0.3 it has reduced to 0.109. You saw this, right? It has reduced. Decision tree has reduced. So still I can reduce it. I can go to the top and I can just put it to be 2, right? Let's put only 1 and run it again. I'll get some values. So in this way, you have to play with the parameters, and there are a lot of parameters for every algorithm. There are not only 2 or 3. For every algorithm, there will be a lot of parameters, and you have to find those parameters and you have to tune them. You have to adjust them accordingly. Still, there is no change. So there is one more parameter somewhere that is affecting it. You have to look for it. Let's see if R square values have changed anything. Oh, see this? The entire thing has changed now. Linear regression still stays on the top, but random forest came to the second position. Previously, decision tree used to be in the second position. Now, random forest improved rapidly. Random forest is giving us 61%. Previously, it was giving 0.45 something. Now it is 0.61. So we adjusted it. In this way, we will be doing fine tuning, changing the parameters. And we'll talk about random forest importance after the break. Yeah, see you all after the break. Yeah, back. I'm sharing the screen. So yeah, I talked about the importance of fine tuning and how we change the parameters. So here there are few things. In fine tuning is a different concept. I'll talk more about it. So for example, if you take this decision tree regressor, in decision tree regressor, you have lots and lots of parameters. You can find these parameters in scikit library and you can play with it. You can add more parameters and you can adjust them, and you can see if you can able to get the more better accuracy. The best example that I just gave you now is this one. Yeah, adjusting the parameters so that random forest came into the second place. Previously it used to be in the 4th place, it came to the 2nd place now. Now let's talk about random forest feature significance. Now random forest, with 200 trees. Importances. And here I will use a little bit of AI. So for the same code, I will add a plot so that you can visually see which feature is contributing more to the random forest feature importance. I have added it. Done. Yeah. So here, Monish, what are you doing? So in the random forest, you can see which columns are more important and which columns are less important. I in the beginning I was talking about a few columns will be more important and few columns will be less important, right? In the beginning of the ML classes. So this is what random forest deals about. Here, area has the highest importance. Any changes that happen to the area directly affects the model. Area has the highest importance in all of the columns. Next is bathrooms, next is air conditioning, and so on. That is what I am showing it here. So this last cell that in this entire project, this is going to be the last cell. We can end this here. This one is specific to random forest and it answers one critical question: which features actually matter the most and when making predictions? Which features are more important and which features are less important? That is what we wanted to find out. With rf dot here, this is the important method. Rf dot feature importance gives us a score for each feature between 0 and 1. All scores add up to 1. If you just add all of this, you will get 1. 0.46 plus 0.14 plus 0.06, 0.05. If you add all of this, you will get 1. So that is how it is divided based on the importance. And we sort from highest to lowest and plot it as a horizontal bar chart, so it is easy to compare. If you look at the chart, the longest bar is the most important feature. In most runs of this data set, area will rank near the top. It is going to be the top. The bigger house tend to be worth always more in any region, whether it is in US or India or anywhere. Always the more the area, the price also increases along with it. Air conditioning is the third place. Number of bathrooms is the second place. So this is extremely useful in real projects because it tells you where to focus your data and collect to put more effort. If area in air conditioning and bathrooms drive 60% of the model's decision, you want to make sure those columns are clean and accurate. Now coming back, this is what I am telling from day 2. Your project will never end with a prediction. Once you predicted the model right, you got the accuracy right, you understood the algorithms right, like what is this coefficient, what is the importance, what it changes a lot. You understood all these things right. After you understanding all these things, again you have to go to the beginning. If you remember this flow that I've taught you, if you remember this flow that I've taught you, after evaluation, after checking the metrics, inspecting the errors, understanding where you need the improvements, again you have to go to the beginning. You will go to the beginning, you will define the problem again for yourself. Since you found out that area is more important, and area contributes to 235 per square feet, and based on this type of data and based on the real life data, again you have to think, again you have to question yourself, what is the use case that I'm talking about, what is the use case that I'm going to perform, and again you have to perform all these operations. Again you have to perform it, and that will be your assessment today. You have to perform again whatever the code we have. Again you have to understand, you have to redo the things from the beginning. You have to again prepare the data. This time you have to be more careful with area, bathrooms, and air cooling, that thing. Again, you have to split the data. Again, you have to train the model. Again, you have to evaluate. This time, you will be training the model with the different parameters, different situations. So, if it also tells you, this also tells you which features you could potentially remove without hurting the performance. So, for example, main road, guest room, hot water heating, basement. I don't see any much contributions from them. So what I do, I simply remove them. I remove them and I'll check the predictions. Because they are not contributing much, why should I put more stress on the model? Why, if it doesn't compare, let's see this area. Area is around 0.56 importance. So when compared to that, what is main road? Main road is very simple aspect. So you can remove main road, you can remove guest room, you can remove hot water heating, and you can redo the model. You can recheck the model. At this time, maybe your accuracy may be increased to, let's say, from 65% to 70%. Next time you will remove basement, or next time you will add something and you will check it. You can add a number of bedrooms plus basement and you can create a future column, like how we have done in the last project. So in this way, you will be removing whatever that is hurting the model, and anything with near zero importance is not contributing, like your main room, guest room, and over hot water heating. And yeah, that is the complete project. This is what I wanted to teach you about regression. Again, whatever I'm gonna teach you is not for creating the best model. I said this in the day one itself. Your end goal is not accuracy. Your end goal is not you getting the model you doing here and there. I mean, how do we say, adjust the settings and getting 80%, 90% accuracies doesn't make you an ML engineer. You have to get this kind of errors. You have to understand what to remove. You have to understand what to put back. You have to understand what feature columns you can add newly. You have to think which has more importance, which has less importance, what is contributing more, what is contributing less. You can use this graph here and this coefficients graph here to understand that. Area is contributing more. And also how much is area changing with the coefficient? $235. That is per square feet. So again, here it is contributing a lot. So you have to put all these things into mind. And yeah, that is the complete project. We loaded the data, encoded the data, encoded with the labeling. We splitted the data. We trained 4 regression algorithms, compared their metrics, visualized their errors, predicted a new house. We explained the linear model's logic. We caught overfitting, and we understood the feature what features matters the most. This is what a complete applied machine learning workflow looks like. This is how it looks like. You start with the data, you understand the data, you clean the data, you split the data, you train it, you test with different models, you get the accuracies, you understand each model, why it is performing so. You try to get what changes have to bring into place to increase the accuracy, and you will go back to the beginning. Again, you will redo the data from whatever you got before. Again, you will split the data. Again, you will train it and you will check the performances. If you are not satisfied with your performance, again you will go back. Again, until and unless you are satisfied with the accuracy, you should always redo the cycle. And this happens also if new data comes into place. For example, today your model is 98% accuracy, and suddenly tomorrow something changes and you get new data. Obviously, again you have to train the model. Usually for Gemini, ChatGPT and all, right, they have few cutoff dates. They don't train their models monthly. They train their models quarterly. So every few quarters of months, you will get a new model. That is why 2.5, and after a few months, like 6 months, you'll get 3, Gemini 3. Again, wait for 6 months, you'll get 3.2. So every few quarterly months, they tend to train their new models with new available data from internet. Yeah. Any doubts still here? And your assignment for this week is going to be, since you understood that area has more importance, main road, guest room, hot water heating doesn't have much importance. You'll go back to the data to the top and you will remove them. You remove those columns, remove those unnecessary columns, and try to redo the entire code. Same code, but remove the columns. And you see these parameters, right? Maunesh, how do I get these parameters? How will I know it? Just go to internet, decision tree regressor. Params. See, these are all the params that are available for decision tree. You have max depth, you have splitter, you have criterion, you have minimum sample width, you have random state, max leaf nodes, and you can get to understand each one of them does and try to play with it. Instead of 2, put 1 and see what happens. Put 0 and see what happens. Put 6, what happens. Try to play with the algorithms. Try to change the parameters for each individual algorithm and try to get the accuracy. And for this data set, 96% of accuracy is possible. I have already done it. I'm not gonna tell you how I did it. But before I started this project to show it to you, I have done it using my own code and I got 96. What I'm trying to say is 96 is possible. It is possible with the code and with right params, with right algorithms. 96 is possible. You do it. You try to get at least 90. Try to get at least 90 or 88 around. Try to change the params here and there. You will definitely get 88. Remove those 3 columns that I said, which are giving less importance. Main road, guest room, and hot water heating. Remove these 3 and change those parameters. Try to rerun the code. You'll get 80. You have to adjust few more parameters in different algorithms. You'll get 88. There is one particular parameter. If you change it, you'll get 92. But I'm leaving that completely to you. You play with it so that you will understand. You will come to know how each parameter will work for every algorithm. You have to search for it. Go to random forest regressor, go to internet, search for the params, get the list, see what each one does. Based on that, edit the code. Yeah. Any doubts, anyone till here? We spoke about it. This is done. Yeah, and this is also a part that I'm adding newly. And this is completely optional. I'm not going to push anyone to do this. If anyone of you are interested, I'll put this on the screen like this. Put your answers in WhatsApp group. What is the difference between supervised and unsupervised? We have talked about it. Why is house price prediction is a regression problem? I have answered it. Why do all models in the project use the same trust time split? I talked about it. What does MAE tell us that RMSE also measures differently? We spoke. Why can decision trees overfit? Just now I've shown you, right? Why it has an overfitting problem. What can be an overfitting problem there? And why can 2 algorithms give different predictions for the same house? Yeah. Yeah, that's all I have to talk about. Any doubts, anyone on this entire project or entire regression class? You're free to ask me. And if anyone are interested, please put those questions. Please answer those questions in the WhatsApp group. And if anyone of answers this, there will be I'll be giving something to them. I mean, already I think Kamala and a few have answered few of the quizzes in the last classes. If you're interested, answer these questions in the WhatsApp group we have. And I will give something to you. It may be a physical product, or it can be something that will help you in a longer run, or it can be a model, a local model that you can use, or it can be something that I bought and I wanted to share it with you, like a subscription for model creation or cloud subscriptions and all. I'll try to compensate in one or the other way. If you can answer this quiz in the group and get the assignment done. Like at least 85 is also fine for me. Or 80 is also fine for me. 80% is also fine for me. If your accuracy, if any of one hits 80, that is fine for me. But it is possible. 96 is also possible. At least try to get 80. And I'll compensate. I'll definitely compensate. I'll give something to you, which will help you. Yeah. So any doubts, anyone? We still have half an hour.
Share the Colab in one more time in the.
Yes.
Thank you.
So next class is going to be on unsupervised, and also we'll be doing a project on sales data, time series data, like from the past few years, whatever the data that is being collected, we'll try to predict the future sales. I started already implementing the project around it. We will be discussing the time series predictions data in the next class, and I will also talk about supervised is completed because classification problem we have done. Regression we have completed today. I'll introduce you with unsupervised in the next class. We'll be dealing with unsupervised and we'll be doing a project on time series predictions. That will be your entire next class. And slowly after that, I will introduce you to this thing. Once ML is completed, we'll go to deep learning and neural networks, deep learning. I'll be introducing you with all these concepts. Slowly, I'll introduce you to LLM. From LLM, I'll show you how you create your own model and you publishing it to something called Hugging Face. There is a website called huggingface.com. Hugging Face, like an awesome website for all the ML engineers. If you don't have an account, please go and create an account in Hugging Face. You will have 2 million plus models for free. They are all open sourced. They are just waiting for you to explore. You no need to pay even 1 rupee to anything. You even have Claude Opus 4.6 with some billions of parameters available for you to try out in Hugging Face. You can just download. I'll tell you, there will be a class where I'll be teaching you how to download these models from internet and how to create your own chat GPTs, your own Geminis, your own Anthropic, how to create. I'll show you. There is a separate class that I have planned for it. But yeah, it is possible. There are a lot of models just waiting for you to explore. Create an account in Hugging Face. You all will be having an account and you will be uploading your work into Hugging Face in the coming classes. And you will also be having a GitHub. If any one of you don't have GitHub, please go and create a GitHub account and also create a LinkedIn account. LinkedIn account, GitHub account, Hugging Face account, Kaggle account. These are what you have to spend your time on because that is what creates your profile. You have to create a profile in such a way that instead of you applying for the jobs, HRs will be contacting you. Once you prepare a complete solid profile, right? You no need to apply a job. The HRs will be messaging you for full-time opportunities, C2C opportunities and all. They only will reach out to you. And I want you all to create that kind of solid portfolios. You can also create your own portfolio. Portfolio, I mean, on your own website that you can showcase to HRs and all technical team. But make sure your whatever portfolio you create, it should add value to others when they look at your portfolio. I have seen nearly like thousands of portfolios which all feel like selfish. Why? Because all portfolios only talk about themselves. Like for even I created one like that, but one of my HR friend told me this small trick. Why should anyone open your portfolio in the first place? They have your resumes, they have your project details. Why should they open your portfolio websites? So why? Because you have to provide them with some blocks, latest blocks, or you have to provide them with some tools. Like I have created my own resume enhancer, stack recommender in the sense you tell it what project you will be creating and it will tell you the stack to create. SQL, like you put in SQL and it will explain the query to you. System design cards, like if you're using Redis caching, you can easily read from it. Like last minute interview preparation. You have to provide some or the other kind of value to the customers or to the people who are visiting your portfolio. Then only people visit your portfolio. Otherwise, what is the reason of people looking at your work? So this is one small trick. Even I didn't know about it. I created. I did not create all of this. When my HR friend told me about this, then I have redone my entire website, and I'm just suggesting you the same. Yeah. Any doubts, anyone? If not, I can give you this time back. Whatever 20 minutes, I think we have more. I'll give you this time back. Please use it. If anyone are interested, please solve the quiz questions and put it in the group. I'll also send the quiz questions. Wait. I'll also share it in the group. So no worries. Even if I end the call, you'll still be able to find them. And I'll also share this presentation with you. So you'll have it. And please complete the assignment. Again, I'm not pushing anything on you. I know some of you are working, some of you have very tight schedules. Only if you're available, only if you have free time, then only do it. Otherwise, it's okay. Try to complete the quiz and try to complete the assignment that I've given. And I'll try to compensate to whoever who have done it. At least even if you didn't get 80%, if you have done some work, please let me know. Send me your GitHub or something. I'll look at it. Even if you tried to do something, that is fine for me.
Updating things on GitHub, some of the homeworks. I did for the first week and second week. I'll have to do for the last week.
Thanks. Please share it in the group or to me. I'll once see.
Yeah, I'll do that.
Yeah, that's it then. Love you all. Take care. If any questions anywhere in the week also, please let me know and I'll answer it back. Take care, everyone.
Thank you, Monesh. Good one. Bye.
Bye.